Hello everyone, so welcome to this second video of Python today. And now we are going to speak about lists. So the same way that a variable can hold a SQL value, such a number like number 5, or a string like hello world, or a boolean value like true, this is like all the things we discussed in the previous video and last week. It can also hold several of them in a data structure known as list. So basically in Python, lists are used to store multiple items in a single variable, and we create them using square brackets. So here you can see that it says this list, this is the name of the variable, and then we have like an open left bracket, and then we have like three strings, which are going to be banana, apple, and cherry. And then later on we can do print this list, and it's going to print like the full list with all its elements. In a similar way, we can do the same with numbers. So we can have like this list equals 5, 8, 99. And then if we print the values, it's going to print the full list with the three values. So basically the idea is to have like a left square bracket, and then all our elements separated by comma. And then we have like a right bracket to close it. And that's, the components that are going to be stored in the list. Something that Python lets you do, which another programming languages don't let you do, is that a list can have very different types of data. So for example, I can have like a list which is going to contain true, a word, and 99. And true is going to be a boolean value, a word is going to be a string, and 99, in this case, a float, a number. And this is going to be good with Python, it's going to eat it. But generally, this is going to learn to do mistakes. So unless it's impossible otherwise, it's always better to try to have the lists containing only one type of data. It's going to make your life easier. And then something very important is that you can also create empty lists, which are going to be important later on when we do the examples. And basically you need to put the name of the list, and then you need to put left and right square brackets without anything in between, like you can see here. And then if you print the list, it's going to just print like an empty list. So obviously empty lists by itself are not very useful, but the interesting thing about empty lists is that we will be able to add things inside the code. So, the list is going to increase as we deal with new data. So something in the list is that the items are ordered. This means that, if we say that a list contains true, a word, 99, the order of the elements in the list is always going to be the same. So true is going to be the first one, a word is going to be the second one, and 99.9 is going to be the third one. Something also very important is that we can change the elements, as we will see on the next slide. And also something quite important is that it allows for duplicate values. So for example, like if I do like my list equals 1 1 1 1 1, so it's going to let me do it. It's going to let me have a list which is going to have the same value a lot of times. There are some other data structures in Python, like the dictionary, which is not going to let you do this, but we are not going to cover this. So it doesn't really matter much for you, just for knowing that it can contain duplicate values. So something quite important, which might surprise to those of you who've never done any programming, is that the very first element, is actually indexed with the number 0, not with the number 1. It's actually indexed with the number 0. The second element with the number 1, and so on. So this is, if you have done programming, you already know this, but if you have never done programming, it might surprise you. So once we create the list, we can access individual elements by using each index as number. So for example, if we create a list which is left square bracket, banana, apple, cherry, right square bracket, then we can do like this list, and then between bracket 0, and this is going to access the first element, which is going to be banana. Or for example, this list between brackets 2, and remember, this is going to be the third element, which is going to be cherry. So then what's interesting is what happens if we try to access the third element. Remember that the element number 3, the third element, is actually going to be the fourth one. So, it's going to be like 0, 1, 2, 3. But obviously this doesn't exist. There is no fourth element in our list. So this is a very common source of mistakes, and Python is going to return an error, which is going to say, index error, like, this index doesn't exist. And then in particular, it says list index out of range, so the number of our index is too big. So let me see, like my list before, for example, has 5 elements. So if I do like number 4, it's going to be fine. But then if I do number 5, it's going to be a mistake. It's going to say that it cannot find it. But any number which is bigger than 4 is going to return exactly the same mistake. So you need to be always very careful that you don't try to access one element that doesn't exist. The next thing that I was saying that we were going to speak about is actually how to change specific items. So this is actually very easy. To change a specific item, we basically address it by its index, and we say equal, and we assign a new value to that number. So for example, here I have like my list, which it contains 5 ones. So for example, like I say my list number 3. Now I want it to be hello. And now if I type my list, you can see that the 4th element, which is the one with an index 3, has been replaced by hello. So this is how you can change like elements that, in a list, like a particular element that you want to change its value. Again, if you try to address an element that doesn't exist, so for example, if I say my list element 7th replaced by hello, it's going to say that this assignment is out of range. So then some of you might be wondering, so if I have a list, with 5 elements, how can I add more elements into it? Because this is something very common, like it's a type of data, it's a variable that might decrease on or increase in size. So in order to do this, we can use the append method, and the append method, it's basically going to add the data at the end of the list. So for example, I have my list here. Remember, it has like 1, 1, 1, hello 1. So the 5th element is going to be a number 1. So I can do, for example, my list append number 2, and now it's going to increase the size of the list by 1. So the list is going to have an extra element, and this element is going to be the new one. And I can say, for example, like my list append by, and again it's going to increase the length of the list by 1 element, and it's going to put the 1 at the end. And now I can change this value, by the way, to these new elements. They are like regular elements of the list. So for example, let's change by, so 0, 1, 2, 3, 4, 5, 6. So it's going to be the index 6. So instead of by, I want it to be like 3, 14. So now it's actually going to be okay, as you can see, because that element exists, so I can replace it. But again, if I try to do the 7th element, the 7th element doesn't exist. It's here. It's going to say that item error out of range. But then if I say append 3.14, it's going to add this one at the end. So we use append to, make the lists increase in size. So the next thing that we are going to speak about are if conditions. So as I say here, so far all the lines of code that we have written have been executed by the computer. But it might be the case that you want some lines to be executed only if a condition is met. So for example, imagine that you are writing some code to program a drone, and the drone is moving around, and the drone is controlled by a person that has a controller in their hands. So for example, when the person presses forward on the controller, you want some rotors to be executed in order that the drone behaves in this way. But you want only those rotors to be executed when the person presses forward. So you can do that kind of behavior, that kind of control behavior with an if condition. And basically what it says here is that an if statement will execute the code it encapsulates only if the condition is true. And remember, true here we mean the Boolean value true that we were speaking about in the previous video. Otherwise, Python is going to ignore that code. And the syntax is as follows. First, it starts with the keyword if. You will see that as soon as I write if, it goes to green, meaning that it recognizes the thing. And then I need to write my condition. And my condition is going to be like true or false, a Boolean operation or a Boolean value as we saw before. And then I'm going to write my code. And it can contain several lines. But it is very important that the code is intended by one tab. So this space here that you can see after the if condition is critical. Because if not, if this space here doesn't exist, the code is not going to be considered part of the if condition. And as you can see here, at the moment we remove that indentation and we go back to the same level, we're out of the if block, and this line is always going to be executed. So for example, this is some very simple code. You can see that we have like initially we assign to the variable a the number 33, and we assign to the variable b the number 200, and we say if b is bigger than a, print this statement b is bigger than a. So in this case, because b is bigger than a, 200 is bigger than 33, is going to print it. But if it was not the case, this line could never be executed. So more or less is what I was saying before. It is very important to understand that the code is indented inside the if block by using a tab space. In the following pictures, the last line is always executed because it's not intended. So here, for example, this is exactly the same as before, but I added this extra line here, like print. This line will always execute. And you can see that it prints b is greater than a because 200 is bigger than 33. But then it also executes this line. But now check this code here. So here a is 33, b is 200, but now I'm checking if a is bigger than b, which is not the case because 33 is not bigger than 200. So this line is actually never executed, but this one, which is after the indentation, is always executed. And as you can see here, if you actually don't indent your code, so if you have like if a bigger than b and then you have straight your code without an indentation, Python is going to give you an error because it's part of the syntax of the if condition that there is going to be one line in the block with an indentation of a tab. Otherwise, it's going to give you an error, expected unindented block. So this is the last slide of this block. Something that is quite important is that we can change the conditions with an elif statement. So for example, I can say like if a is bigger than b, print this, elif b bigger than a, print this. So I can have like if, elif, I can have many of them, as many conditions as I need. But finally, I can use an else statement at the end, which is going to catch anything that was not catched by any previous condition. So if a is bigger than b, it's going to print that. Otherwise, elif a equal b, so they are the same, it's going to print this one. Otherwise, if none of these conditions have been met, then this line is going to be executed. And the last thing I wanted to say here is that the else statement doesn't need to appear after the elif. It can appear after the initial if. So for example, if you have something like if condition something something else something something, this else statement is going to be executed when this condition is not executed, when this condition is not met. So you don't need to add any kind of elif statement. So it can be used, you can have like an if in isolation, use if code and that's it. You can have like if elif, or you can have if elif else, or you can have like if else, or you can have like if elif, as many as you need. So there are many variations that you can write your code. So this is the ending of this block. So the next slides are going to be, the next video is going to be about for statements.